Okay, so here's the video on how to get the memo for a clock pin set. Um, so basically, yeah, so this works for any pin set. You could do like 7 pin set. You could do like a 6 like alternate pin set. It works for like flip pin sets as well. Um, Anyways, yeah, so here's how you do it. So basically, first we're going to go to search for inverse matrix calculator. And then we can just use this one. This is the one I've used a bunch of times. Um, and yeah, has all these annoying ads, but oh well. Anyways, so yeah, so if your pin set, basically you want to set a matrix with the dimension equal to the number of moves in your pin set. So 7 pin sets all have 14 moves, right? Because there's 7 simul moves, which each have 2 moves. So we're gonna do. I'm gonna try to do with Zhang because I mean everyone knows Zhang. And so yeah, so that's 14 by 14, right? So click on Set Matrix, and it'll give the 14 by 14 grid here. And yeah, the way it works is we have each these columns, right? And each of these columns is going to represent a move in the pin set, and then each row is going to represent a clock. So what that looks like is, at least the way I do it, is the first 5 of the rows are C, U, L, D, or C, U, R, D, and L on the front, right? So starting in the middle and then sort of going clockwise. And then you do an X2, and then it's those same clocks on the back. So C, U, R, D, and L on the back. Those are 6 through 10. And the corners are just UR, DR, DL, UL on the front. And those are the last 4. Right? And then the way I like to do it is I just do like whatever the pin order I'm using is. That's the order I put in for these moves. And then if there's ever a simul move, I just do the up pin move and then the down pin move. Works pretty well. Anyways, so what does that sort of look like? Okay, so with Zhang, right, the first move is the lowercase dl move, right? And so the up pin part of the move would be this. So this move is our first move, right? And so the way we're going to figure out what to put in this column is by doing a +1, right? And so what you'll notice is that all of the clocks in the cross are now at 1, right? So that means we're going to put a 1 right here for each of them, right? Because remember, so 1 is C, C's at 1, U, R, D, and L are also all at 1. Now we can look on the back, and I mean, since it's a front move, it hasn't affected anything on the back, any of the cross pieces on the back, right? So it's kind of obvious, but yeah, so all the pieces on the back that are in the cross are still at 0, which means 6 to 10 we can leave blank. And then we have the corners, right? So UR, DR, and UL have been affected, right? So UR, DR, and UL all get a 1. And then number 13 is the DL move. I might have misspoke there. I said, yeah, UR, DR, and UL all at 1. And then DL is the one that is still at 0, so we can just leave that blank as well. So that's our first move, and then the next move is the bottom, the back pin part of the lowercase dl move, right? And so with this, right, we can see it doesn't affect any of the cross pieces on the front. So that means 0 to 5 we can leave blank. If we look on the back, though, it has affected some of the clocks, right? And so what you notice is that we have C, U, and L. right? So you might be thinking we just do C, U, and L. And then of course we need to get our corner, which is the DL corner, which is at 1. This is actually not correct, right? And that's because if you actually take a closer look at the back, these aren't at 1, they're at 11, which in this case we're going to put in as -1, right? So for the back pin moves, right, because it's all relative to the front, when you do a +1, it'll do a -1 on the back. So we just need to make sure we put that in. And then you pretty much do the same thing for the rest of the pin set. So I can do the R move as well, right? So we have R +1, and then we get all of the cross pieces except for L, right? And if you remember, since we're going around clockwise, L is number 5, which means this is going to look like this. And then for the corners, it's just the 2 R corners, which are 1 and 11 and 12, right? And then on the back, we have these 4 pieces are at -1 and not R. So C, U, not R, and then D and L. And then for our corners, yep, it's the 2 L corners, right? What's nice is that if you ever have a simo move like this, the corners that are in the front side are like the corners that aren't in the back side. So like what you'll notice is like none of these, like neither the 2 sides of the simo move do not share any of the same corners, which is like kind of obvious, but it's kind of useful. Anyway, so I'm just gonna put in the rest of the moves into the matrix, because like I think it's pretty clear now how to do it, and it's just boring. It's just 5 more moves. So yeah. Okay, so I finished filling out the matrix here, right? So now I can just press the fill empty cells with 0 button, and if we calculate, this should be the inverse matrix that we're looking for. All right, so now we have the inverse matrix, which is great. And so the first thing to note right here is that with the inverse matrix, the columns and the rows have effectively switched, right? So if you remember before, each column represented a move. Well, now each row represents a move, and each column represents a clock. And then the second thing to note is that the inverse matrix is actually the calculations you need to get from a solved clock to a certain state on the clock, right? And which that means that we have to sort of take everything as if it was negative. All right. So what that means is that, let's take a look at our first move, right? This was previously this column, right? So that means this row represents the up pin part of the DL move, right? And so based on what we have right here, remember this is going to be actually plus, and if there's no minus, if it's not negative, then it's going to be minus. So we're going to have plus the U, so it's U. Wait a second. My handwriting is kind of bad, so you're gonna have to work with that. Right, and this is minus L, and then this is minus R, and then this is minus UR. So with what we currently have, is this showing up? Yeah. So with what we currently have, this is the sort of calculation that we would get from the matrix. Now, if we try it, right? So in this state, obviously it's a solved clock, except when you do this. So if we try that, we can see like doing that calculation works, right? So we have u, -1, minus L, which is also a -1, equals 0, minus R, which is a 0, and then minus UR, which is a -1. So 0 minus -1 is 1. So the number we would get is 1, right? So that's great. Except there's some issues with that. And the issues is that that's not how you actually do memo, like when you're doing solves. So the question is, how do we turn the memo in that form into like a more useful sort of variant? All right, so yeah, so there's the memo, right? I put it into a Google Doc because it's easier to see than the Post-it note. Anyways, so here is what we currently have. But the thing that's nice about Zang that makes it easier to show is that we already know like what the memo, because this is, we know this is M2, right? And like, or in Tommy 7 Simul and People 7 Simul, it's M2, and we know that M2 is R to DR plus U to, plus L to U, right? And so here is what we're starting with, and here's what we want to get to. So how do we do that? Well, the first thing that can make it a lot easier is we have this corner, right? And what's fun about the corners is that you'll notice that they have two sides. So if we look at the UR corner, right, it's at +1 right now. But if we look at the back side, it's at -1, which means we can actually replace this negative UR with, or actually, wait, I wanted to do this in like the next line down. We could replace the negative UR with a plus DR, right? And that's a lot more useful. And you'll see that how that is in a second. Okay, so that's nice. And then, you know, we can sort of reorder everything. So it's like, we do it like dr minus r plus u minus L here, right? And so that's just like, we can just do that because of how arithmetic works. So this is looking closer to this, but here we're using distances and here we're using subtraction. And so how do we fix that, right? So the way it works is, if you saw Tommy's original 7 Simul video, he mentioned that whenever you have something minus something else, right? So if I had like D or C minus D, you can actually do the second thing, the distance from the second thing to the first thing, right? So C minus D would be -2 minus 0. And that's the same as D to C, right? And it's the same if you like, right, like it goes like this, right? This is like -2 minus 1, which is the same as -3. I don't know if was that even, I feel like that was like completely out of the frame. Oh well. You get the idea, right? And so now we can change this to, we can just change it to what we have down here, right? And so what you want to sort of create are these pairs, right, where you have a positive and a negative. Because if you can create the pairs, you can make these sort of distance pairs. And with those, that's how you get it to this form of having like the pairs, and then you just only use addition, right? And what you'll notice as well is that there are two positive numbers here and two negative numbers. And what you want to try to do as well, that can make memo better, is if you use the ones that are near each other, which is kind of obvious, but like, right, obviously it wouldn't really make sense to do like the distance from dr to L, right? Or the distance from L to dr rather, because they're on opposite sides of the clock and they're also like pretty far away anyways. So you want to try to get pairs of clocks that are close together. And usually it's not too difficult to figure that out. But yeah, so the sort of ideas that you want to keep in mind are, how can I make these pairs of positive and negative numbers for the clocks? And then how do I get the pairs to be, close together to make memo easier? So that's most of what you need to know for getting the memo from the pinset, except there are a few extra things to note, and there's an important thing about slash moves. Okay, so here's the thing with the slash moves, right? So I took the slash moves from the matrix. This is number 7, right? So again, remember when you're getting the actual memo out, you have to change this from negative to positive. So this is positive C minus U minus D, and then plus R on the back, plus L on the back, and then plus these two corners. And then here's the other one, right? So this is negative R and negative L on the front, minus C on the back, plus U and D on the back, and then plus these other two corners, right? And that's what we have. And yeah, so looking at this, right, we'll start by looking at the back part of the slash move because it's easier. For this, we can pretty much just pair things up as normal, right? Except what you'll notice is that there are only 7 clocks, or I mean, it's kind of a lot. Actually, it's the most in any same calculation, but like there's an odd number of clocks, which is the more important part. And this, you'll find calculations with the odd number of clocks for like pretty much all like 7/7 pinsets. Like for the slash moves for those pinsets. And so when you get into this situation, basically what you need to do is like you're gonna end with something like this D here, where like, so you'll notice it's all alone. It's not part of a pair, and that's just because like there's 7 clocks, so it can't be part of a pair. But what you'll notice is that they're still only using pluses here. We're not using any subtraction. And that's something that you generally you want to try to avoid subtraction. So yeah, anyway, so here is like the calculation for the normal slash move. And with this, what we had to do, you'll notice like I actually had to change the corners here, because before it was plus UR plus DL, and this obviously doesn't work because we only have 2 negatives and 5 positives, so we can't even form the 3 pairs. So basically what we need to do is just change this to a negative dr, and that makes it so we can make this pair. The important thing here is that this is one of the calculations. The calculation that I actually use is different. It's looks like this. Right, and this calculation, what you notice, is actually the same as this, except it's like the moves, the clock's on the other side, so it's basically just starting from the other side. And then it also has this minus out front, and this is because you have to invert what you end up with. Now I think on here, which is the pseudosync document, the pseudosync document, all of the M5s are like that because that's what I do. So I just sort of put them like that. Most of the time there's a way of moving around changing the corners to get it so you can get something like this where you don't need to have the minus out front. But for one of the cases, you actually can't do that. You just need to do the minus. You can either do it like this, or you could do something like L to C minus R, right? This would also work, except this, instead of inverting it after doing all the calculations, you have to just do subtraction, which I don't like, so I didn't put this. Right, so this is, yeah. Anyways, so for slash moves, that's basically how you do it. You want to try to avoid, again, you want to try to avoid minuses, and you want to try to get the pairs to be of clocks that are close together. Slash can be a little confusing, but also the thing about slash calculations, they're usually really long because they necessarily have to take up all the clocks on the clock. So if one of them is short, then the other one's going to be really long, right? So as you can see for the line case, like this is what, like something crazy. It's like 9 clocks, which is only 3. So yeah, that's basically all you need to know about getting the memo from the inverse matrix. All right, and here's just the last thing that I want to talk about. So if you're in a situation where you are trying to figure out, like this case is right tilt, obviously. And so here there's a 6 simul pinset, which means it's actually like 12 moves. And so you just want to set a matrix that's 12 moves, right? And that works great for each of the columns, right? Because we have 12 columns now. But what you'll notice is that we only have 12 rows. And you might think that's an issue, but it's actually not an issue, because these two on the front, C and U, and C and R on the back, are always going to stay together, which means instead of each needing their own row, they can share a row. So basically, row 1 represents C and U on the front, and then 2, 3, and 4 represent the rest of the cross clocks on the front, and then 5 is going to represent C and R on the back, and then these other 3 are the rest of the cross clocks on the back, and then the corners are going to stay the same. So yeah, that's pretty much everything you need to know about getting the memo from the matrix, like from the pinset rather. This is probably kind of confusing. I don't know if I explained it that well, but if you have any questions, you can just like put them in the comments, as always.